Hello. So yeah, I'm going to talk about inside PromQL. Oh, here we go. Right, slides are up. Good. Yeah, so my name is Bryan Boreham. I work for Grafana Labs. I have worked on Prometheus. It's pretty much 7 years to the day since my first PR on Prometheus, and I am a maintainer. I committed to do this talk because every time I work inside the PromQL engine, I have to figure it out from scratch. It's pretty complicated, and I thought, someone should write this down, and so that someone is me. What happened is this is basically a 90-minute talk, but the slot is only 25 minutes. Incidentally, if you could put the time remaining up, that would be helpful. I don't know if whoever did that yesterday. So the talk is going to be very, very high level. There will be a blog post because that is running about 12 pages currently, so you can read all the detail. Anyway, a lot to get through. Let's get going. So this is the big picture. This is what I'm going to be talking about. I thought, well, that's kind of a boring picture. This is what we're doing. We have all the information, we have all the data, we are controlling the world with our dashboards, we're at the nexus of the universe with full information. But this is the way the software works. So we'll come back to this picture a few times. Let me see if I can, so we're going to start with the PromQL language. It goes through a parser, creates this thing called an abstract syntax tree. Then we'll get very deep into the engine and how it interacts with storage, and it produces results, hopefully. So very high level, PromQL as a query language is built up from a series of building blocks. Selectors, which fetch the raw data, the metrics, functions like abs and rate, aggregations, sum, max, things like that, and operators. And that's it. It is nominally a pretty simple language. So just to take an example for the sake of illustration, if I feed this into the PromQL parser, I get a tree. Computer trees grow downwards from the root. The whole thing is driven by walking this tree. When a PromQL query is executing inside the engine, everything that happens by walking down this tree, kind of get to the leaves of the tree, fetch the data, and then come up the tree, compute things, come up the tree, compute things. There is no query planner. Nothing happens in a different order to the way you wrote it. Well, very little. There's very little kind of sophisticated cleverness like you might find in a database like Postgres. But it is some sort of database. Anyway, moving on. We have just looked at the abstract syntax tree, which is constructed from the PromQL language that you feed in. So we look at how data is fetched from storage. So there's some data. So I'm illustrating series here, time series. Each series in PromQL is identified by labels, which are name-value pairs. So there's the name of the metric, in this case HTTP requests total, and it has a couple of labels, one called method, one called status. And the particular set of unique values of those labels identifies the series. Inside Prometheus, every series has got another identifier, which is just a number. Inside Prometheus, it's a 64-bit number, but I've chosen small decimal numbers here, and that's the ID that I put on the left there. So we just sort of follow those numbers around and see what happens. So Prometheus builds an index of the labels. So the main two labels here are method and status. So those things are in a map in Go code inside the storage. And then for each label, we have all of the possible values. For each name, we have all the values. And those are listed out. And then against those, all of the series IDs that match those labels. So every, on this picture, we've got 5 series. So there are 5 series matching method, and there are 5 series matching status, and they sort of appear in different places. And when we come to query the data, we're going to use that to sort of figure out what we want to look at. These sets of IDs inside the code, they go by a strange name, which is postings. I don't know why, but this is the traditional name for these things inside many databases, not just Prometheus. But sometimes you find this in the code, this word postings, and that's exactly what it means, those lists of numbers. So one more list of numbers, because the name of the series itself is a label, and it has an internal name, underscore, underscore, name, underscore, underscore. And in this example, all of the 5 series match that. All right? So to look up, so that's how the data is indexed when it's been stored. If we come back to PromQL, when we give a query, we're going to go to that same index and we're going to look things up. So yeah, I thought that would look good on the big screen. So the first thing we come to in PromQL is selectors. Selectors that ask us to go get data. So here's an example. The selectors look very much like the whole name of the whole identity of the metric that I put up earlier. But you can just ask for a subset of labels, or no labels at all, just the name. You have a lot of flexibility in how you write a selector. So they look very similar, but the difference between the identity of a series and a selector asking for series is kind of in how it's treated. So if I write a PromQL query like this, internally it's translated into this, that I've asked for a particular name and a status. So then we go to the index, we look up the name, and we get one list of numbers. We look up the status, and we get another list of numbers, and we take the intersection of those. And that's how we know which series we're going to use inside our query. So that's looking up the index. Now we're going to look at how the actual data points, which are called samples, are fetched from the series. So let's kind of go sideways to what are we going to do with this? In our dashboards, sometimes we want basically just one number. Like what is the memory usage right now? And in Prometheus, that's called an instant query. And sometimes we want a whole set of numbers over time, like the one on the right, and that's called a range query. And they work very differently, and I want to explain exactly how that works because it's kind of core to a number of things. If I ran a query in Grafana, in the Grafana dashboard program, and that's a range query, and I really want to draw your attention to the fact that all the points coming out are regularly spaced. A range query requests a set of answers at evenly spaced intervals. That's what you ask for when you send in a range query. And that's, Prometheus will try very, very hard to give you those points exactly evenly spaced. When you're doing math, arithmetic on the numbers, you want them all to arrive at the same time, right? Because if somebody's wanting the sum of them, you need to add them up at the same point in time, or any other arithmetic. So this is absolutely what's wanted internally, and this is what comes out. But it trips people up about. I answer a lot of questions about Prometheus, and multiple times per week, people are getting tripped up by this one thing. So I really want to emphasize it. So the other kind of query, if in Grafana, if you flip that range thing to instant, it looks totally different. You get out just the kind of identity of the series, and you get the results. And you get them out in a table. So that's we'll come back to this. That's looking at a range query versus an instant query. So we moved through our flow to the PromQL engine, and we're going to start building up the expression out of the other parts. So next, functions. Here's a very simple function, abs. Takes the absolute value of what you give it. And conceptually, you give it a column of numbers, a column of samples all at the same time, and it gives you the same column back again, but after doing some arithmetic. I mean, in this case, it flips the -2 to a 2. That's how. There's like 75 functions in PromQL, and about a third of them work this way, that they take what's called an instant vector. That's all of the points in one column, all aligned in time, and they give you back the same kind of a thing. So the other kind of function, the other big grouping, is functions that take a range vector. And I've used rate as an example here. So the function in PromQL takes a little expression in square brackets, which is a time window. And so when PromQL is evaluating a function like rate, it's looking across time. So in the documentation, the thing that it takes in is called a range vector. This is a very confusing term to pick. Trying to look at the people who wrote this thing in the first place. So the thing that you type in is called a range query, and the thing that's inside the mechanics of the language is called a range vector. And they're very, very different, and you really don't need to think about this. But what you do need to think about is the points over time that are going in. So I drew another picture. Series can start and stop as we move through time. So if you make a range query, it's going to step through time looking at the points. And series can start and stop within the whole range that you're looking at. And the function that you've called will do its best with the data that you give it. So I want to return to this picture, which is what happens what you see when you ask for a range query. And there's a trick to visualize, to actually see what the internals of PromQL sees when you are evaluating something like rate. And the trick is you take that range and flip it to an instant query, and then put a range on the query. So up here. And in Grafana, the simplest thing to do is this special magic dollar range thing, that means the whole width of the panel that I'm looking at. When you do this, Grafana will show you the actual points. In fact, Prometheus is doing all the work. Prometheus returns. So this is the range vector, essentially. This is all the points at their actual timestamps. And this is the same query, right? If you do a range query, Prometheus will nicely arrange the output in these very, very regular rows. The input to that query is likely to look more like this, is likely to be ragged and have data all over the place. So that's the little trick. Use an instant query with a range to see the underlying data points. And this is my number one go-to. People have a lot of puzzles about what's going on in PromQL, and I say, look at the underlying data. Because 99.9% of the time, PromQL did what you asked it to do. And the problem is that you didn't understand what the data looked like when you're mystified. All right, so here's my points. As I evaluate something like rate, I'm going to take a window of time, and as I evaluate my range query, PromQL will move the window forward in time. And all of the points that fit into that window go into the function. It actually came as a surprise to me. Matthias said every time he comes to these things, he learns things. So every time I do a talk, I learn things. And it came as a surprise to me that the fetching of the data is actually inextricably linked with the evaluation of a function like rate. That it kind of steps through pulling out the individual points. It manages a sliding window of data. It does not fetch all of the points up front and then go looking at them. As you evaluate the function, it steps through and pulls more points. All right, that's very a lot of words. Next thing we're going to talk about is aggregations. So an aggregation is something like sum. So just to emphasize how it works, the query that you type in is parsed, is transformed into a data structure, which is the syntax tree, and the evaluation walks down the tree. So in this case, it's a selector. This is the raw series. This is the 5-minute window. Evaluation of rate will walk through those points, and it outputs those points, which are then summed up. So let's look at how the summing works. So we say sum by status. What it will do is pull out all of the different status values in the whole query. So there are 3 possible values. And then it starts matching them up. So this is done once. This is an optimization that was put into Prometheus a few months ago. It used to do this on every point. It used to do the map lookup of how does this combination work. Now it does it just once for the whole range query. And then as you step through the points, because series can start and stop over the time of the range, it still needs to look individually at each point and decide what the output is. But that is one of the speed-ups. Also note, the series name has disappeared. Most of the time when you call a function, the name goes away. Because the rate of HTTP requests total is not HTTP requests total. So we take the name away. Generally, that happens quite early on. There's another optimization. There's an optional feature in Prometheus to do that later, because that makes the code more efficient. That's an experimental feature that I merged about 2 weeks ago, I think. But anyway, nominally, conceptually, you always lose the name of the series as you do computations on it. Totally different kind of aggregation, top K. So K is a constant here. I want the top 10, the top 2, the top 1,000, whatever I put in, that's K. In this case, I've done it on the raw series to illustrate that we actually don't lose the name in this case. So top K works. If you ask for the top 2, it will construct a priority queue of 2 things, and it will just walk down the data. So there's one thing so far. Each time we add a new thing to the series, or each time we look at a series, we say, is it the lowest? So we want the top K, but we're always going to look at, is this the lowest one? So 41's the lowest. At this point, 3045 is the highest, but what matters is that it's not, it was higher than the lowest. So we put it into the priority queue. We're always maintaining the lowest one at the top of the queue. So 462 is higher than the lowest. We put that in the queue. And from now on, I mean, I only have one more series in my example, but all, if nothing else goes into the priority queue, it does nothing. It's always just comparing one number. So that's actually relatively fast, even though it seems like a very complicated operation. So the output of top K is the whole series, including its identity, including its name. So that's very different from calling a function like rate, or even doing something like sum, where you lose the name. Top K, you always get the name. You get the whole identity of the series comes out. How am I doing? Oh, should be stopping soon. OK, one more thing, operators. So an operator like minus, in this case, I'm subtracting total memory from free memory. Free memory from total memory. Presumably, that's the memory in use. And so if I just put the operator in, PromQL will match up all of the labels exactly on both sides. So it does a one-for-one match, and then we lose the name. Always lose the name. So that's pretty simple. You can do very complicated things with join. I call these things joins because that's what databases generally call them. Joining 2 things, joining 2 sets of series. Prometheus documentation really doesn't talk about joins, it talks about operators. Same thing. So there's this pattern, and Arve talked about ways to try and make this easier yesterday in his talk. There's a pattern where we have some additional information on something, and we always have the value 1. So this pattern turns up a lot, and the reason it has the value 1 is so that we can multiply it by something that we're interested in, and we still get the same number. So that's how we use this pattern. We're asking it to match on some set of labels. Group left says we're doing a many-to-one join. I like the word. And then we can actually add some more information from the one side. So just to illustrate the way the code works, it takes what you have asked to join on and extracts just those parts from the series on both sides. So that in the code, that's called the signature of each series. And that is the many-to-one mapping. That on one side, there's one mapping for each, and on the other side, there can be several things mapping to the same place. This is done for every point in a range query. And this is one of the slowest, most expensive things you can do in PromQL. We might be able to pull a lot of that work to just do it once, but it is complicated because of this thing where series can start and stop in the middle of a query. So the output, in this case, we take the unique labels from the left-hand side. We lose the name, always lose the name. And we add in the label that we asked for on the right-hand side. So that's how operators work in PromQL. So we nearly reached the end. I'm pretty much out of time. Keep going? Yeah, OK. Final results. So PromQL outputs series, a set of numbers for a range query. Range queries are always sorted, sorted by labels. And the reason is that these numbers, there's no one point in time where you could decide which order you wanted by the numbers. So range queries are always sorted by the labels. When you talk to Prometheus, you get JSON out, but the PromQL engine itself just outputs the series, the raw numbers. OK, so we pretty much reached, this is how it works.
All right. Thank you, Bryan. Yeah, we're pretty much out of time, so I think next speaker can already get set up. While we change laptops, we can maybe ask one, at most 2 questions. So if anyone has a question. Yes. And it's not in the very back, so that's perfect.
Thank you. Just real fast, like you said that there was no query planner. Like, is it because there is no performance to gain from it, or it's just something that should be implemented is missing? Yeah,
there's no query planner because no one wrote one, not because there's no benefit. A couple of people have written completely new PromQL engines. So there's one that Bartek, I think, worked on for Thanos. And there's one that some of my colleagues worked on in Mimir. So certainly there's scope to try and do more clever things. But in PromQL, as it stands, there's everything just kind of happens the way you wrote it.
I'm not up to date with the discussions, but do you know if there are discussions to allow Prometheus using custom engines, like a plug-and-play approach?
Oh, so using a custom engine, yeah. So like I say, there different projects have implemented PromQL engines. There's no provision in the code to kind of plug a different engine into Prometheus, but you certainly can do that in Thanos. And in Mimir, it's a command line parameter. You pick one or the other. Yeah, maybe in future it could be pluggable in Prometheus.
Especially for like Thanos and Mimir, where they're distributed systems, we want to have a query planner. But so far it went pretty OK without one in Prometheus itself. OK, yeah, great questions. Thank you again, Bryan.
Thank you.